We will start with student combinations of capacitance, right? Combination of capacitors. Correct. I'll share the recording. If possible, you keep on writing, right? Student, this is the symbol of capacitors. Correct. Unit is, this is capacitor, symbol is C. C is the symbol of capacitor. And its unit is farad, right? Its unit is farad. But most probably in every question, you'll be getting, the unit you'll be getting like nanofarad, picofarad, microfarad, right? So you'll be getting nano, pico and micro. That means 1 nanofarad is how much? 10 to the power minus 9 farad. 1 microfarad, that is how much? 10 to the power minus 6 farad. 1 millifarad rate, how much? 10 to the power minus 3 farad. 1 picofarad, right? Pico means 10 to the power minus 12 farad. So these units you are going to get most probably when you will be solving the numericals. So combination of capacitors, in your class 10th you have learned about series and parallel, right? Of resistances. That means here something reverse. That means you see, if two resistors are connected in series, right? This is R1, this is R2. What is R equivalent, students? R equivalent is equal to R1 plus R2. This is series connection, right? But what happens in parallel connection, students? In parallel connection, let this is the resistance. This is the resistance, correct? This is R1, this is R2, right? These two parallel resistances can be converted into one resistance, right? Equivalent resistance. This can be converted into one resistance. This is R equivalent. What is the formula for that? That is 1 R equivalent is equal to how much? 1 by R1 plus 1 by R2. Are you getting on? What we make usually, the LCM is R1 into R2. Here R1 plus R2, right? This is the formula for R equivalent, correct? 1 by R equivalent, but we are always supposed to find R equivalent is equal to, we just reciprocate R1 into R2 by R1 plus R2. Keep in mind, these are the formula for resistors. These are the resistors that you have learnt about in class 10th, and once again you will learn about this in chapter 3, right? This is all about resistances. But the same thing doesn't happen in capacitance, right? We have discussed in the last class. Once again, I am reminding you what is the formula for combinations of capacitor in series and combination of capacitor in parallel, right? Before to that, one thing you just remember, students, in series connection what happens and in parallel connection what happens, right? This is series connection, right? This is the voltage V, this is the resistance R1, this is the resistance R2, and here the current is flowing, I amount of current flowing. In series, student, in series connection, this is series connection, here the current remains same. Series connection, current remains same, correct? But the voltage divides. This is V1, this is V2. Total voltage V is equal to V1 plus V2, right? Total voltage V is equal to V1 plus V2. So remember, in series connection, the current remains same, the voltage divides, right? But what happens in parallel connection, student? What happens in parallel connection? See here. If I'll be connecting two circuits in parallel, two resistors in parallel, this resistance is R1, this resistance is R2, and I have connected one voltage to this source, that is V, right? Here total current let going I, so here let the current is going I2 and here the current is going I1, right? That means here the voltage remains same. Voltage remain same. Voltage remains same means if you will take and connect a voltmeter here, it will show this much volt. How much voltage given to the circuit, that you will see here. If this is V, same voltage will be like 12 volt we are giving. If you will measure the voltage across this resistance R2, you will also get 12 volt. If you will measure the voltage across this R1, you will also get 12 volt. Here the voltage remains same, but the current divides. In parallel, the current divides, right? I divides. Very important, remember this thing. In series connection, the current remains same. In parallel connection, the current divides. In series connection, the voltage divides, and in parallel connection, the current divides. It's the most important thing. Here we are saying about current. Now the same thing will be understood in case of a capacitance, right? Once again, you write all those things, then we'll go to the next. capacitance. Okay, students, let's divide the set into two parts. Okay, one part will be taken as series. Here the two capacitors. This is C1, this is C2, right? Both are connected to series to a common voltage source V. This is series connection, right? Series connection. Already you have learned all those things in the copies previous class. Once again, I'm reminding you, right? And let's go to parallel connection. Which connection? Parallel connection, correct? Parallel connection means, student, see this one. This connection is parallel connection. Like resistor, we have replaced the resistors by capacitors, right? This is the total voltage source. One thing, student, I told you. There where shouting is current. Here it will be replaced by charge. In series, charge remains same, voltage divides. In parallel, if total charge Q is going, let here capacitance is C1, here capacitance is C2. So here the charge will be going Q1, here the charge will be going Q2. Current divides, we are saying in resistors. But in capacitors, we will be saying it charge divides, right? This is the voltage V, this is the voltage V. But here the potential is going to be same. Potential is going to be same. So in series connection, the reverse of capacitance happens. The reverse of resistance happens. That means 1 by C equivalent will be here 1 by C1 plus 1 by C2. But here C equivalent will be equal to C1 plus C2. Are you getting my point? Already we have learned this one. 1 by C equivalent is equal to 1 by C1 plus 1 by C2. That means the LCM is C1 C2 and the upper C1 plus C2. If it is supposed to get C equivalent, then it is C1 plus C2. It will be reciprocated C1 into C2 by C1 plus C2. Correct? This is in case of series. Just remember. But in case of parallel, what happens? C equivalent is equal to C1 plus C2. With this formula, we'll be moving on, right? Here, student, total capacitance C1, this is C2. And in series, the equivalent capacitance is C1 into C2 by C1 plus C2. If I'll be asking you, what is the voltage V1 here? What is the voltage V2 here? Students, you remember Q is equal to CV. Yes or no? Q is charge. What is Q? Charge. C is what? Capacitance. C is capacitance and V is voltage. If I'm asking here the voltage drop, students, V1 which is going to be how much? Sir, C1 into Q, correct. V2 is going to be how much? C1, C2 into Q, because same charge is flowing. So total voltage is how much, students? See here, total voltage V is equal to how much? V1 plus V2. That means C1Q plus C2Q. Yes or no? Because voltage device V is equal to V1 plus V2. Getting my point or not? This is Q is equal to CV. I asked what is the voltage drop here? Sir, capacitance, they are connected in series. So same amount of charge is flowing. So here voltage V1 is equal to how much? Student, Q is equal to CV. See one thing. So V is going to how much? Q by C. So right here, Q1, Q by C1. Yes or no? V2 is equal to how much? Q is equal to CV. Then V2 is going to be how much? Q by C2. Are you getting? So if I'll be saying V1 plus V2, then what you have to do? Q by C1 plus Q by C2. Then you take common, students, Q. You take Q common, right? Just see here. You take Q common, students. If I'll be taking Q common, then it will be 1 by C1 plus 1 by C2. Yes or no? Then from here, I can find total voltage V is equal to Q into 1 by C equivalent. That 1 by C equivalent is equal to 1 by C1 plus 1 by C2, because this is the equivalent capacitor. Getting all? So you remember the formula for series and parallel. In series, what happens? This is the method of finding the capacitance. And in parallel, C equivalent is equal to C1 plus 2. See your copies in the class, already these things discussed. Today, I'll be giving some numerical, some examples on this, right? Let's take an example. Let's take example. See, I've given a circuit here. There is a capacitance. This is 2 microfarad, right? This is 3 microfarad. This is 6 microfarad, right? Just simply say me all quickly if I've remembered the formula, right? How much voltage I am given? Let 30 volt. How much voltage given, students? 30 volt. How these three capacitors are connected? Students, how these three capacitors are connected? Subrat.
Sir, in series.
So what is the formula for series? 1 by C equivalent is equal to how much? 1 by C1 plus 1 by C2 plus 1 by C3. That means three capacitance. That will be 1 by 2 plus 1 by 3 plus 1 by 6. Yes or no? Getting or not? LCM is how much? 6. You take 3 plus 2 plus 1. That is how much? 6 by 6. How much 6 by 6? 1 microfarad. Student, remember here it is coming 1 microfarad. And that you have taken C equivalent, correct? So C equivalent is equal to how much? 1 by 1 microfarad. But if so many students, what they usually do, how much they got here, they take that value as equivalent. But once again, remember you have to remind, you have to reciprocate. Getting my point or not?
Yes, sir.
Now you say me what is the total charge flowing? Now say me charge
30 coulomb.
Now write charge flow through the battery. Write charge flow right? Charge flow through the battery. Charge flow through the battery, how much will be, students? Q is equal to how much? CV, na? CV means C equivalent into total voltage. C equivalent is how much?
Sir, 1 microfarad.
1 microfarad. Voltage is how much?
30.
30 into 1 is going to be how much? 30 microcoulomb. Unit of charge is what? Coulomb. Yes or no, students?
Yes, sir.
Yes, sir.
Say me energy stored. What is the formula for energy stored in the capacitor? What is the formula for energy stored in the capacitor? Anyone? Subrat. Somyaranjan. Energy stored in the capacitor. What is the formula? Next class, I will ask everyone all the formulas, right? Half CV square, correct? Yes or no? So that means half. C is how much? 1 microfarad. Into voltage is how much? 30 square, right? Getting or not? So 900 microjoule by 2, because unit of energy is joule, na? Correct or not? So that is 450 microjoule. All understood?
Yes, sir.
Understood or not?
Yes, sir.
Okay. All wrote. Just write this one all. I'll share the notes. You'll update, right? Let's take a example of parallel connection, right? Students, draw the circuit. There is a capacitor. Let 1 microfarad. There is a capacitor. 2 microfarad. Correct. And let there is a capacitor. 3 microfarad. Both are connected to a voltage source of 10 volt. How much voltage, students? 10 volt. Participate all. How many capacitors are connected? Students? How many
3
capacitors?
capacitors.
What are the value? One is 1 microfarad, another is 2 microfarad, another one is 3 microfarad, right? Getting or not? So they are connected in parallel, right? So in parallel combination, what is the C equivalent? What we do usually? C1 plus C2 plus C3, right? So 1 plus 2 plus 3, how much? 6 microfarad. Is that clear to all? And student, how much charge will be flowing? Total charge Q. Q is going to be how much? CV, right? C equivalent into V. What is C equivalent? 6 microfarad. What is the total voltage?
So 10.
10. Then it's going to be how much?
So 60 microcoulomb.
60 microcoulomb. All understood? Right? Total
Yes.
energy, total energy stored. Student, energy stored in the combination, right? Energy stored in the combination. Energy stored in the combination is how much? Half CV square, right? Half C equivalent into V square. But how much half C equivalent is how much? 6, na, correct? Into 10 into 10. It is going to be how much? 300 microjoule. All understood? Students, all understood or not? All wrote? Are you listening all?
Yes, sir.
Yes, sir.
All wrote? Students, same, there was another formula for capacitance also in the frame of area and distance between two parallel plate capacitors. What is the formula for that? Priyanka,
Yes, sir.
Ashish, what is the formula for another formula for capacitance? Surti, Snigdha, Soumyaranjan, Tanvi, Vijay, Uditansu. Are you listening all? Another formula for capacitance. Do you remember? Two parallel plate capacitors. Last class I taught you insertion of dielectrics. Area of the plates is A, distance between them is D. What is the formula for capacitance? Epsilon naught A by D. Remembered or not? What is A?
Yes, sir.
Area of the plates. You forgot, right? What is D? Distance between the two parallel plate capacitors. So if I will be giving you a question on this, like just draw a diagram. We want to find the equivalent capacitance. That means students, draw a circuit like this. This is one. This is another one. This is another one. This is another one. This is another one, right? This length is A. This length is D. This length is A. And this length is D, right? And this length is also again A. The circuit is here you this is A, correct? So this one. Understood? Right. So here he is asking the expression, right? Is asking the expression for the equivalent capacitance. The expression for the equivalent capacitance of the system shown above, right? And student, here A is the area of cross section of the plate. Student, how these three capacitors are connected semi? That means this is the ground, right? This gap is also D. How the three capacitors are connected here? Just semi. Area of every plate is this area of every plate that is given in the question also, right? Area of every plate is A, right? A is the cross-sectional area. A is the cross-sectional area of one of the plate. Any idea, Subrat, how the plates are connected?
In series.
See properly. There will be just see here. This is one capacitance, right? Correct or not? This is also one capacitance. This is also one capacitance. Correct, na? Every pair. So if I'll draw the equivalent, you can see here. This is one capacitance. This is one capacitance. This is one capacitance. It seems to be series, right? You are thinking this seems to be series, correct or not? That's why you told series. Getting my point down? Subrat,
Yes, sir.
you are thinking this is one capacitor. This is one capacitor. This is one capacitor, and both are connected back to back. So, sir, three are connected in series, right?
Yes, sir.
But you say me, if I'm giving some charge, right? If I'm giving some charge to this place, what will happen? All will get same charge.
No, sir.
Are you getting my point? Normally, by seeing, you are thinking that no, sir, everything is going. I'm giving some charge, back to back connected. But do you think all the charge will be same in each case? If all the charge will not be same, then how can you say that it is connected in series? Getting the logic or not? But one thing is confirmed. If I will be finding capacitance of this, then this is going to be how much? Epsilon naught A by D, correct? Yes or no? If I'm
Yes,
going to
sir.
find the capacitance of this, then this is going to be how much? C2? The same epsilon naught A by D. If I'll be finding the capacitance of this branch, it is going to be how much? C3 is epsilon naught A by D, correct? Getting or not? So as the charge is getting divided, so it is not connected in series. Getting my point or not? The three capacitors are in parallel. Understood all? The three
Yes, sir.
capacitors are in parallel. If three capacitors are in parallel, then total is how much? C1 plus C2 plus C3. Simple addition. Correct or not? Epsilon naught A by D, because all are having same dimension. Epsilon naught A by C here. One important thing here. Students, capacitance between, normally we'll be thinking epsilon naught A by D for this one. But this capacitance is produced, the plate is same, but the area is more, the distance is more or not between the ground. Getting the students? Getting or not?
Yes, sir.
This is D. This distance is how much? Also D, na? So we are going to find the capacitance between these two. So will it be D or 2D?
2D.
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 Then again here, what is the distance D? Then the capacitance will be between this and the ground, right? Then that is, it will be D or 3D.
3D.
Understood how the confusion are getting? So normally, if in this question, if you have separated everything, then you could have taken C1 is equal to epsilon A by D, C2 is equal to also epsilon A by D, C3 is equal to epsilon A by D. But he has kept everything blank. That means you have to take the capacitance combined. So this is epsilon A, this is epsilon A by 2D, plus this will be epsilon A by 3D. Understood all? Subrat getting? Soumyaranjan.
Yes.
So we are finding the capacitance between the top plate and the ground. Then 1 plus 1 by 2 plus 1 by 3. That is how much? 11 by 6 epsilon naught A by D. If area of the plate will be given and value of epsilon naught you know, and D will be given in the question, then you can find the exact value. Getting or not, students?
Yes, sir.